Today's topic is graphing functions, and this will be a little bit of a review for you, but it'll be good for us to see how to do this again and the procedure. Anytime they want you to graph a function, you got to think of input and output, and the easiest way to graph an equation is if y is already by itself, or if y is solved for. So what do I mean by that? Well, the first one here, a, if they want us to graph y equals 2x plus 1, y is already isolated, it's already by itself. And that makes it very simple for us to put in some points. So when we're graphing, we're going to input stuff for x and get some outputs. Depending on what graph we're dealing with will depend on what are some smart inputs that we should use. Everything's pretty standard with this equation. We have y equals 2x plus 1. This means that since y is always our dependent variable, because y depends on what x is going to be. So we're going to double x and then add 1 to get y. But we get to choose what x values we want to use. So I like to just try 0, 1, and 2, if possible, just to get some nice easy points set up. So if I do 2 times 0, I'm putting 0 in for x and get plus 1. So 2 times 0 is 0, add 1, and I get 1. So this is a point that I can put on my graph. So 0, 1, which is right there. Now if I put 1 in for x and solve for y, I go 2 times 1 plus 1, or 2 plus 1, which is 3. So 1, 3 is a point. So over 1, up 3. There's that point. And then lastly, I can plug in 2, and I get 2 times 2 plus 1, or 4 plus 1, which is 5. So 2, 5. Right here. Now this pattern will continue forever in both directions. We have to remember too that I could have put in any x value that I wanted to. Any possible real number. Fractions, decimals, anything. So we can connect these dots and we can see that this forms a consistent pattern. And this will continue downwards and upwards forever. And there we go, we have a graph of that line. Coming up in chapter 5, I'm going to show you a much faster way to get a graph, but this is something you can always turn to. You can plug in, make your own little XY chart and plug in values that you want. So that is one way that you can do that, but like I said, chapter 5, I'm going to show you a faster way to graph. And my last example for today is another equation that we want to graph. Now it is possible to make your XY chart right from here, but like I had mentioned before, sometimes it's easier, and most of actually it is easier, if we solve for y. So you'll remember way back to when we were solving for specific variables, but not necessarily getting a number answer. That's where I needed you to know that, so that, or this is where I needed you to know that, so we could solve for y. So to solve for y, I'm going to add 3x to both sides. And you'll see why in chapter 5 as well that it's nice to put things in terms of y. So I could say 10 plus 3x, or I can say positive 3x plus 10. Both of these are positive. So I can rewrite it like that. You'll also find out why I like to put the x term first. Alright, now here's the issue. I want to just solve for y, but I have that being times 2. So I have to divide everything by 2, and I have to divide this whole side by 2. So we've got y equals 3 halves x plus 10 divided by 2, which is 5. Alright, so again, we'll want to choose some nice easy values here for my xy chart. So I want things that are going to be divisible by 2. Do I necessarily have to do that? No. But we're going to take a little bit of a shortcut here. So I'm going to go 0. If x is 0, I take 3 over 2 times 0, and I get 0 plus 5. So 0, 5 is one of my points. 1, 2, 3, 4, 5. And then I'm going to plug in, let's try 2. So here's the trick. 3 over 2, and if I put 2 in here plus 5, we're going to solve for y. I can take, here's the shortcut, I can do 2 divided by 2, which is 1, and then take 1 times 3 to get 3. So really this is 3 plus 5, and I get 8. So 2, 8. 1, 2, 3, 4, and there we go. Now I'm going to run out of space if I continue further, so you got a couple options. You could put in a negative number if you want to, or just extend your graph. So let's just see what happens if I put negative 2 in. So I would get negative 2 divided by 2, which is negative 1 times 3. I get negative 3 plus 5, which is 2. So negative 2, 2, which is right here. Now, just for one last quick example here, I can show you that when we connect these lines, and this will be the last thing I show. Ooh, that was horrible. So that should be a straight line, just like that. Pretty bad. If I were to put 1 in for x, I would get 3 halves, or that's 1.5 plus 5, which is 6.5 when I add 1 to it, or 5 to it, sorry. So over 1, up 6.5. So 1, 2, 3, 4, 5, 6, and 6.5 would be right there. So it'd still be on our line, it's just that we'd have to deal with the decimal if we did that. So those are the 2 examples I wanted us to check out today, and we'll continue with this tomorrow.